Para empezar, es un honor para mí presentar al ingeniero Walter Sperko. Walter Sperko, voy a dar una pequeña reseña, es un consultor metalúrgico y de ingeniería de soldadura. Su especialidad es trabajar con fabricantes que sueldan y sueldan productos que deben cumplir con los requerimientos del Código de Calderas y Recipientes a Presión, ASME, y Código ASME 31 para tuberías a presión. Él ha sido miembro de ASME y se convirtió en miembro del Comité ASME, sección 9, en 1981, y recientemente completó 6 años de servicio como presidente. Enseña un seminario de 3 días sobre cómo usar la sección 9 de la norma, que ha estado enseñando desde 1983 y ha publicado actualizaciones de los cambios de la sección 9 en cada nueva versión desde 1998. Y estos documentos se publican en su sitio web. Y él observó la sección 9 desde todo lo que requería desde su inicio en la publicación hace 75 años y cómo este documento ha ido cambiando pues, a través del tiempo. Le damos la bienvenida con un fuerte aplauso al ingeniero Walter Sperko.
Good afternoon, or buenas tardes maybe. It's a little bit late in the day. Thank you. I would like to take a few moments here at the beginning to thank the various parties who've invited me here to Peru. It's my first time in Peru. So far, I'm enjoying what I'm seeing. Planning on going up into the mountains tomorrow with my wife and her sister, so making a little bit of vacation out of this, so they thank you also. What I'm going to talk about is ASME codes, what it was like in the good old days when we first had welding codes. And I would point out that this is not about research. This is about taking the research that you do and turning it into products that people build and making sure those products work properly and work safely. As you heard in the introduction, I'm a member of various ASME committees. When you become a committee member, one of the things that you agree to is that anytime you talk about the code and what the code says, and you interpret the code, that you have to tell the audience that it's your personal opinion. So what you're going to hear is my personal opinion about the code, not the official opinion. So the code. Why do we have codes? Well, we have codes because we had an industrial revolution. Steam became a prime mover for transportation, for factories, for heating. In the 1800s, the early 1900s, boilers routinely blew up and killed people. It was not a good situation. ASME got involved because ASME was already a recognized standards development body. In 1884, ASME published the Performance Test Code for boilers. It was a standard that allowed an organization to measure the power output of a boiler consistently and uniformly. The Boiler Code Committee was established in 1911, and it published the first boiler code in 1914. The boiler code was written so that it could be adopted by local jurisdiction to ensure safe design, manufacture, and testing of steam boilers. The first edition was 5x8 format. It was small. It was 119 pages long. Today, the boiler code is 8.5 by 11 format, and it's about this big, over 20,000 pages. Welding was included in the 1914 edition of the code. Who knew Welded joints, the ultimate tensile strength of a longitudinal joint that has been properly welded by the forging process, which hardly anybody uses anymore, shall be taken as 28,500 pounds per square inch with steel plates having a range of tensile strength from 47 to 55,000 pounds per square inch. So welding has been around for a long time and was in the early code. The boiler code became the Boiler and Pressure Vessel Code in 1928 when Section 8 was published covering unfired pressure vessels. The rules on welding were contained in Section 1, in Section 3, in Section 8, in Section 4. Wait a minute, did I say Section 3? Was there a Section 3 in 1941? There was indeed. It was locomotive boilers, steam engines. Section 3 was last published as locomotive boilers in 1948. In 1963, it became the nuclear code. Section 9, published in 1941. It was at that time a 5x8 format, small book. It was 47 pages, 5 pages of which were a filler metal specification covering stick electrodes, today's 6010, 7010, 8010, and similar other electrodes, including sheet metal type electrodes. The 2017 edition of the code is 8.5 by 11 format and 350 pages long. The early edition of the code had this specification, the early edition of Section 9 had this specification, which is specification ASTM A233. It covered stick electrodes. We know that the content of Section 9 included how to write a welding procedure, that is the technical content of the welding procedure specification, the welding procedure being direction that you provide to the welder, the welding engineer provides to the welder, and the qualification of that procedure, which is basically a test that demonstrates by mechanically testing a test piece that the joint will develop a strength level that is comparable to the base materials being used for the test piece. It also contained requirements for testing welders, for testing welding operators at that time. We'll talk more about that later, for their ability to follow the welding procedure and to make a sound weld. The details of construction, that is the joint designs, whether the joint was single V grooves, a groove weld, a fillet weld, how much reinforcement was required, whether or not any undercut was permitted, did it have to be X-ray quality, all of that information continued to be present in the construction codes, that is in Section 1, Section 8, and so on. So, what Section 9 covers: how to write a welding procedure, how to qualify it, how to qualify the welders. If you look at today's code, it also covers the same thing for brazing and for plastic fusion. The 1941 edition was different from today's code, but it's truly amazing how much was present in the 1941 code that we find today. There were only 3 welding processes permitted: carbon arc, shielded metal arc, and oxy-fuel gas. I don't know anybody that uses carbon arc welding today. Lots of people still use shielded metal arc, good old stick welding, and there's still a little bit of oxy-fuel gas welding being done. The forms, 1941 edition had forms. They weren't mandatory, but they contained information that you were required to put in your welding procedure. So, the early forms, this is an example of an early form. It started out, it says specification number, it said date, It says the welding process shall be done by metal arc process. The base material shall conform to the specifications for, and then it says you insert the specifications that this welding procedure covers. And then the filler metal shall conform to the classification number, and you fill in the blanks, and specification, insert the title of the specification. Welding shall be done in the whatever the positions are. So it was really a simple way of writing a welding procedure, a lot easier than we have today. You just basically fill in the blanks. Interestingly, the information that was covered in the forms is what we call non-essential variables today. That is information you're required to include in the welding procedure, but does not have to be qualified. The following were essential variables: a change in the electrode classification, an increase in the rod or electrode diameter, a change in the mean electrode voltage or amperage of plus 15% from that qualified, a change in the type of groove, a change in the number of passes plus or minus 25% in a groove weld. You essentially had to qualify what you were going to weld. It went on to talk about a decrease in the groove angle, a decrease in the root opening, an increase in the root face thickness, or addition or omission of a backing strip. If you changed any of those, as described here, you had to requalify. These are not variables today. A change in welding position. A separate qualification test had to be done for each position, and that included the flat position. So if you were going to weld overhead, you had to qualify the procedure overhead. If you were going to weld vertically, you had to qualify it vertically. Going to weld horizontally, you had to qualify the procedure in the horizontal position. A decrease in preheat temperature, similar to what we have today, although today we say a decrease in preheat temperature, but the welding procedure can go 55 degrees C lower than what was used on the test piece. A change in the post-weld heat treatment temperature range. That's pretty tight. Today we have much more open requirements for qualifying procedures with post-weld heat treatment. Back in the good old days, a 3/8 inch thick qualification test piece qualified the production weld up to 3/4 of an inch in thickness. Well, what we see here is what most of us that deal with the code are familiar with. It's the 2T rule. If you qualify a procedure using some test piece that has some thickness, you're usually qualified for twice that, kind of rule of thumb. But it said that if you qualified the procedure on a test piece that was 1 inch thick, there was no upper limit on how thick a material you could weld. And you might say, good grief, that's not very conservative. Keep in mind, this was 1941. Nobody was building anything that was much over an inch or so in thickness at that time. 2 tension tests, 4 bend tests were required for groove weld procedure qualification. Does that sound familiar? In the 1941 edition, same requirement in today's edition. A free bend test was also required. What's a free bend test? A free bend test, you take a sample of the material, typically 1.5 inches wide. You put it between, you take that sample of material, you put 2 scribe lines down just inside the toes of the weld. You put it in a fixture and you bend it until it bends until the sides are parallel, and then you measure the elongation between those 2 scribe lines. And the code said that the elongation had to be 30% for welds that were heat treated, 20% for welds that were not heat treated. You also had to do a tension test if you were going to make fillet welds. You had to do a tension test, a shear tension test, and a free bend test for fillet welds. So a shear tension test looked like this. And then there is a second shear tension test where instead of the welds, in this case the welds are transverse to the joint. In this case the welds are parallel to the joint. You had to do a tension test. And it had to pass certain criteria. So today's rules, a groove weld qualification qualifies all fillet welds. In 1941, if you were going to make fillet welds, you had to qualify fillet welds. A change in the base metal specification from one P number to another P number. Boy, does that sound familiar. That's exactly what the code says today. Almost, not quite. But it goes on to say a change in the specification from one base metal welded from one O number to another O number. What's an O number? Well, lo and behold, there is a P number table in the 1941 edition of the code, or a listing of materials that groups materials of similar welding characteristics together for purposes of qualification. If you qualify any material in that group, that test qualifies all materials in that group. And you'll notice that it says P number 1, O number 1. And if we go down a little further, we go down to P number 7, we see at P number 7, it's P number 1, O number 2. Well, P number 7 materials are what are today P8s, the austenitic stainless steels. They required separate qualifications. So what's the deal with O number? That's coming. Patience. Right? There were P numbers and O numbers. P numbers were grouping materials for procedure qualification. P numbers similar to today's P numbers with some slight rearrangements. O numbers were a grouping system for operator qualification. The person who did the welding back in 1941 was known as an operator. So there were two systems in place, one for procedures, one for operators. And I'm sure a lot of you that have dealt with the code have asked yourselves, why does ASME call P numbers P numbers? Why didn't they call them M numbers for materials, or simply call them material grouping numbers or something? Well, here's why. Back in 1941, there was a grouping system for procedures, a separate grouping system for operators. And then the other question that you've probably all asked yourselves, those of you who have dealt with the code, why is there no P number 2? There's P number 1, and then the code jumps to P number 3. Well, in 1941, there was a P number 2. It was wrought iron. Nobody makes wrought iron anymore, I guess. So, it's gone since we don't use it anymore. So, procedures. We've seen a lot of similarities for procedures. How about welders? For welder qualification, the code said qualification tests described herein are specially devised to determine the operator's ability to produce sound weld metal. So, operator, why did the code call the person who's doing the welding an operator? Well, that's because the person who was doing the welding operated this machine. This was a motor generator set. It was a diesel engine or gasoline engine or an AC motor that turned a DC generator. So the operator operated that piece of equipment. So the person doing the welding was known as an operator. So what about operators? Essential variables for operators. There were 4 essential variables for operators. A change in base metal O number. So looking at the table, there were only 2 O numbers. There was O number 1 for carbon steels and low alloy steels, O number 2 for stainlesses. A change from one filler metal specification to another. There were 3 filler metal specifications. One covered carbon steel electrodes. Another one covered low alloy steel electrodes. The third one covered stainless steel electrodes. Sometime in the mid-1960s, ASTM stopped publishing filler metal specifications and turned that job over to the American Welding Society. The American Welding Society today publishes the A5 series filler metal specifications. So, why are filler metal specifications in ASME identified as SFA specifications? You've probably looked at that and scratched your head and said, I have no idea why they call them SFA specifications. Well, the explanation is pretty straightforward. When ASME adopts a material specification for boiler code construction, ASME goes to some other standards publishing organization like ASTM. And that standard is reviewed by Section 2 committee. It's a materials subgroup committee or a materials standards committee. And it has to meet certain criteria. The material has to have defined chemical composition. It has to have defined tensile strength, yield strength, elongation. If it's going to be used for low toughness service, it has to have toughness requirements. It has to have certain characteristics in it that allow the material to allow code users to be confident that that material will be what it is supposed to be when it's installed in a boiler or a pressure vessel. And after Section 2 committee gets done reviewing it, they say this material is now special. So ASME publishes SA 106, Special A106. Keeping in mind that filler metal specifications were originally ASTM standards, what Section 2 committee, or actually what Section 9 committee did when it adopted when it adopted the filler metal specifications to distinguish them from base metal specifications, which would be SA or SB for non-ferrous materials, Section 2 committee simply put in SFA Special Filler A233. So that's where the SF comes from. What about operators? Continuing on, a change in progression from uphill to downhill and vice versa. There's another one that has not changed since it was introduced to the industry in 1941. A change in welding positions. Welding positions, 1941 edition. You had 1G, 2G, 6G, you had 1G, 2G for horizontal tests, 3G for vertical, 4G for overhead, 5G for pipe tests. There was no 6G, and there was also no OG position. Bad joke, sorry. Right? So for fillet wells, you had the 1F, the 2F, the 3F, the 4F, fillet well test positions. And then this diagram, which I'm sure all of you can sit down and explain to me thoroughly, because it's such a simple diagram to read and understand. Actually, no, it's not. Once you figure it out, it's a pretty cool diagram, works like a charm, but it's been in the code since 1941. What were the testing requirements? Welders had to test in each position. Testing in any position on plate also qualified flat. Same rule we have today. You know, if a welder can weld horizontally or vertically or overhead, he can weld flat. 5G qualified flat, vertical, and overhead. What about the testing of welders? How much did you, what kind of test did the welder have to take? Well, if a welder was going to use groove welds and fillet welds, he had to do a groove weld test. He also had to do a fillet weld test. Groove weld test on 3/8 inch thick material qualified the welder to 3/4 of an inch in thickness. Same as procedure. One face bend was required. One root bend was required. Okay. A 1 inch thick test gave the welder unlimited thickness. You had to do 2 side bends if it was a plate test. Acceptance criteria. No crack or other defect, open defect exceeding 1/8 inch in length. Corner cracks are acceptable. Same thing we have today. So, been in the code forever. If you tested the welder for pipe, on pipe, because pipe positions were multi-positions, you had to do 4 tests. You know. The testing on pipe, however, was different from today. When you take out your bend test specimens on pipe, They took them out at the 3, 6, 9, and 12 o'clock positions rather than at the 45-degree marks where we take them out today. So that's changed. There was some discussion here several years back when we were trying to get ISO 9606 and Section 9 to match up better. The ISO 9606 standard had inadvertently been changed to have its test specimens removed, as you see in this example on the screen. Was not intended, I don't think, but we ultimately discussed where bend test specimens should be removed. And the argument was made that probably the most difficult position for a welder to make a weld on a piece of pipe is coming down from underneath, up and around, on the inside, on one side of the weld. That, you know, that 45-degree mark was really a challenge for the welder to make a sound weld. So the ISO committee agreed to put the bend test specimens in the same location that ASME has. So that was a good thing. Does this look familiar? Bend test fixture, same bend test fixture that we have in the code today, although it only has one set of dimensions. It doesn't have a table of dimensions. Section 9 in its early renditions only covered carbon low alloy and stainless steels. All those materials could withstand 20% elongation in a bend test fixture, so the standard bend test fixture took your bend test specimen and wrapped it around a 2T radius, so a 3/4 inch thick specimen, you wrapped it around a 1.5 inch, or 3/8 inch thick specimen, you wrapped it around a 3/4 inch radius. That put 20% strain in the outer fibers of that bend test specimen. That rule is still with us today. Section 9 required that you bend test welder fillet weld tests. How do you do that? Well, the welder welded up a test piece. It'd be a piece of plate. You cut a strip out. But what the welder did was he had a square groove and a gap, and he put 2 fillet welds in on both sides on a backing strip, and then filled it out. And then what you did was you removed the weld reinforcement, you removed the backing strip, and you put that specimen with the root side, you put that specimen back in this fixture with the root side downward, and if there was any incomplete penetration on the root side, the specimen would fracture. So actually a pretty cool test. This is an interesting paragraph. Retesting. If an operator is given an immediate retest, the operator shall make 2 tests, both of which must pass. If there's evidence that the operator has been given further training, a complete retest shall be made. We read the code today. What it says is pretty simple. If the welder fails the test and you give him an immediate retest, he jumps up and down and says, I can do this, I can do this, I can do this. I want to take another test. He has to take 2. Right? If you send him over in the corner and say, go practice over there, learn how to weld a little bit more, and maybe tomorrow when you come back, we'll give you the test again, and maybe tomorrow I won't stand over your shoulder and make you nervous while you're welding your test coupon. Right? So give him more training. He only has to do 1 test. Right? There was a 3-month rule. If a welder didn't use the process every 3 months, he had to retest. That became a 6-month rule in the mid-1980s. So my early career, when I actually had a job, when I had to deal with welders and make sure they stayed qualified and that kind of stuff, it was every 3 months you had to make sure the welders had welded with the process, and otherwise they'd lose them. Moving forward, Section 9 had no really big changes during its first 10 years. New section on welding non-ferrous materials. Actually, I guess it was a big change. A whole new section, welding non-ferrous materials, was added in 1948. It said the early edition only covered ferrous materials. We added non-ferrous. 1952, there was some good clarification and separation out of welder qualification requirements from procedure qualification requirements. You look at the rules that were there for welders and procedure qualification, they were pretty similar. A very important aspect of working with Section 9 is to recognize that when you're qualifying a procedure, you're demonstrating the properties of the weld. And the things that affect the properties of the weld are different from the things that affect the welder's ability to deposit sound weld metal. And the code clearly reflects those two differences. So a secret of using Section 9 is to be sure that you're paying attention and only using the rules for procedure qualification when you're writing and qualifying a procedure, and don't confuse the rules for procedure with the rules for performance. 1959, new section was added on brazing, so Section 9 became welding and brazing qualifications. 1974, the code was rewritten into today's format. That is today's format with the tables, separate tables for each process. Go back to the 1971 and earlier editions of Section 9. Everything was in text. All the processes were identified and all the variables were identified. For shielded metal arc welding, you did this. For submerged arc welding, you did that. For gas metal or for fuel gas welding, you did that. For gas metal arc, you had to deal with that. In 1974, we introduced the tables with the variables: essential, non-essential, supplementary, essential. At that time, there were 93 variables for procedures, 13 variables for performance, 11 variables for brazers, 4 variables for brazers, 11 for brazing procedures, 4 for brazers. The biggest and most controversial change that occurred in 1974 was the elimination of position from the requirements for procedure qualification. That is, prior to 1974, as I mentioned earlier, if you were going to weld in vertical position, your procedure had to be qualified in vertical position. That was eliminated in 1974 because, for the first time, Section 9 defined why you qualified welding procedures. And what Section 9 said was that the purpose of welding procedure specification, procedure qualification record is to determine that the weldment proposed for construction is capable of providing the required properties for its intended application. If a change in a welding condition did not affect the mechanical properties of the joint, it was not going to be an essential variable. The underlying assumption is, of course, that the welder made a sound weld. So if you have a sound weld and you make the weld in a flat position, you make the weld in a vertical position, you make a weld in a horizontal position, you make the weld in overhead, does that change the properties of the weld such that you can measure a difference consistently and uniformly? No. If you have a sound weld, the weld doesn't know and it doesn't care what position it was welded in, right? Unless you're welding unobtainium. If you're welding unobtainium, it knows and it cares. But unobtainium's not in the code, so, and good luck with getting unobtainium, right? I would point out here that, this is one area where research data is important. We use whether or not a welding condition affects the mechanical properties of the weld as a basis for assigning, determining whether a variable is essential or non-essential. And we do that based on research work that people have done. So those of you who are doing research, thank you. Keep up the good work. All right. Since 1974, changes have been incremental. We've added new materials. In fact, you open the code up and probably 25% of the pages in the code are the P-number tables. New materials. New welding processes. Section 9 had 3 in 1941. We have 20 welding processes today, and including hybrid welding, where you're doing laser MIG or laser TIG or some hybrid variations, and the code is wide open on the number of hybrid variations that can happen. In the 2000 addenda, we allowed people to use standard welding procedures. The American Welding Society in the 1990s decided to gather data from the industry and write a collection of standard welding procedures for materials we knew how to weld: carbon steel, stainless to carbon, TIG welding, stick welding, MIG welding, flux core welding. AWS wrote a collection. Right now there are probably 40 standard welding procedures published by the American Welding Society. Instead of going out and going into Section 9, reading QW 200, going out and buying test coupon material, doing your 2-tension tests, doing your 4-bend tests, maybe spending $2,000 or $3,000 going through that process and writing the procedure and then submitting it to your customer to get it approved. Instead of doing that, you can go to AWS and for, I don't know, I think it's $275, you can buy a standard welding procedure. And all you have to do to adopt that procedure, qualify one welder following that procedure, write down certain information, put your company name on the welding procedure, and you're done. The big benefit to standard welding procedures, when you submit it to a customer, what's the customer going to say? This doesn't meet the code? I mean, it's an AWS publication. It's a nationally recognized standard. So standard welding procedures cover material thicknesses from 1/8 of an inch in thickness up to 1.5 inches in thickness. Carbon steels in the as-welded and heat-treated condition. Stainless steels, as-welded condition. Stainless to carbon, as-welded condition. So if you're involved in construction where you need a welding procedure, the first place you should be looking is standard welding procedures. 2013, we added plastic fusion. Section 9's name changed again. Changed from welding and brazing to welding, brazing, and fusing. In Section 9, we also, in 2013, added Part QG. What actually happened in 2012 was we had written the QF requirements for plastic fusion. And of course, when you write standards, you don't sit down with a blank piece of paper and start writing a standard. What you do is you find something that's similar and you modify it. And of course, what the plastic fusion task group did was they took QW, and where it said welding, they changed it to plastic fusion. And all the administrative requirements that were in the welding section were going to be repeated again in the plastic fusion section. So the committee decided to take all that administrative stuff out, put it in QG as a standalone section. That way, we didn't have to worry about every time we changed an administrative requirement in QW, we had to go make sure we also changed it in QB and in QF. So administrative stuff got extracted. Section 9 committee meets 4 times a year. The dates of committee meetings are published on my website. They're also published on ASME's website. Section 9 committee meets on Monday. That's where the working groups are, and that's where the fun is. We have all the technical discussions at working group meetings on Monday of Code Week. Section 9 committee meets on Tuesday. That's a little more formal. There's less hollering and screaming and that kind of thing going on at the committee meeting than there is in the working groups. Meetings are open to the public. If any of you ever have an opportunity to sit in on a Section 9 committee meeting or Boiler Code committee meetings, I encourage you to do so. We meet in different cities around the U.S. on a regular basis. So, and as they say, as you say, gracias. Thank you. Thank you. Thank you. Thank you. Okay.
Bueno, si alguien tuviese alguna pregunta para el ingeniero Sperko.
Do you have any questions?
Una pregunta. Aquí al frente, me parece. Oh, bueno, ahí al...
Yes.
Tengo que hacer una pregunta al doctor Sperko, que que è stata siempre por mí una inquietud. ¿Por qué en el código ASME la corriente de soldadura no es considerada variable esencial, mientras en otros códigos la corriente de soldadura es considerada variable esencial? Por ejemplo, un acero SA36 se puede soldar en ASME y la corriente no es variable esencial. Lo mismo acero soldato col código AWS, la corriente de soldadura se vuelve variable esencial.
Okay. The question is why is current not a variable? Sorry, why is current not an essential variable in ASME code? ASME code is a set of basic requirements. It tells people who design and build ASME products, here are a set of rules. Thou shalt do this. Here are a set of prohibitions. Thou may not do this. Everywhere else in the gray area in between, you get to use your engineering judgment. So just a basic philosophy, right? The reason ASME doesn't require you to limit the amperage that you use to what you used when you qualified is because we expect a welding engineer to put amperage ranges down that are appropriate for whatever the processes are and the materials are that you're going to use in construction. Now, if toughness is a requirement, then Section 9 limits the heat input to whatever was used on the test coupon. So when toughness is a requirement, which is the main thing that's affected by larger bead size or smaller bead sizes, ASME says, well, you're only allowed to put in as much heat input as you qualified. But we leave it up to the welding engineer to pick and specify to the welder an appropriate set of voltage, amperage, travel speed, as the welding engineer sees fit, unless impact testing is a requirement, then he has to make sure that the welder doesn't exceed the qualified heat input. I don't know that that answers your question, but that's the underlying philosophy, that we leave it up to the welding engineer. Sorry, let me just back up and give you the famous line. Section 9 spells out a minimum set of requirements, and the code is not a substitute for education, experience, or sound engineering judgment. We expect welding engineers to know what they're doing and do a good job. Section 9 requirements, and we have this argument in the ISO committees on a regular basis, Section 9 requirements are a basic screening requirement. I can qualify a welding procedure, and I can turn around and write a welding procedure that simply does not work if I don't know what I'm doing. So, like in general fabrication of boilers and pressure vessels, we depend on the fabricators to really understand the technology and use the technology properly. May not be a satisfying answer, but that's the way we look at it. Other questions?
Muchísimas gracias.
Okay.
Mr. Sperko, good night.
Hi.
Well, first of all, just to say thank you again, because along my career you've helped me several times asking some questions I sent. So thank you for answering messages from some somebody you didn't
Somebody
know at the time,
somebody I
from
don't know.
somewhere you didn't know at the time. Thank you for that.
I'm more than happy to help anybody who has questions about how to use Section 9. Feel free to send emails, but don't be a pest. Okay? Okay.
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 Well, maybe the answer to my question will be similar to the answer to the first question. I think it's related.
Yeah.
But I'm going to describe a situation that I have faced along my career several times. Somebody during the qualification or the fabrication process proposed a specific practice, and welding engineering judgment tells everybody that it's not correct. But then comes the typical comment, and the typical comment is, show me where it is forbidden in the code. If it is not forbidden, I can do it. So what do you think of that kind of answer?
The code is only able to address limited amounts of requirements, and we have to keep those requirements pretty basic. If we wrote rules that required everybody to address everything and qualify everything, the qualification process would be prohibitively expensive and for not very much reason. If somebody writes a welding procedure and you don't think it's going to work, what you might want to do is say, I'm going to come visit you and I want you to show me how this works. If you have a welding engineer that specifies an amperage range for a 3/16 electrode of 100 to 350 amps, and you don't think it's going to work at 100 amps, ask him to demonstrate. Set the machine at 100 amps and put that 3/16 electrode in there. And when he does that, he'll find out very quickly why they call it stick welding. Right? Okay. That's all I can tell you. Okay.
Muchas gracias. Me parece el doctor Méndez tenía una pregunta aquí adelante.
Okay. One more.
So my question is, when you mentioned the use and the need for research to the code, right? And I'm in a AWS R&D committee, and something we started to do recently is to team up with the D11, because as they write the code, sometimes they have questions, and sometimes we as researchers are doing things that might or might not go anywhere. But if we talk, we have a chance of getting some orientation and you getting some results. So we wanted to bring up, and we can follow up later, is that would be fantastic to hear your thoughts informally or formally, and help us direct the research right in a good direction. And I say this now here in this public forum because it might come in handy for Peru too, doing this type of interactions.
Actually, ASME has a limited liability corporation, ASME Standards Technology LLC, which has research money that's available for people that want to do research projects on specific subjects where the committees need further technical study. We just completed a study recently where where Section 9 committee wanted to know if you're doing hot wire TIG or cold wire TIG and you have heat input requirements, does the hot wire, the energy from the hot wire, do you have to add that to the energy from the TIG arc? Or, and it turns out the results of the study was a wash. If you used hot wire, you adjusted the amperage a little bit, and it didn't affect the toughness going from one method to the other. So and there was research money associated with that. So if there are code issues where people need things to be clarified, you know, there is research money available for not only for you to do the research, but there's money available for you know, from ASME to help out with that.
Thanks.
Yeah. Okay.
Muchas gracias. Le damos las gracias al ingeniero Sperko.
Good. Thank you. Yeah, thank you.